Hello students, this is Shailaja Vibhute. In the last video we have discussed about the observations made by Hallwash, experimental study of photoelectric effect, laws of photoelectric effect and Einstein's explanation of photoelectric effect. Today let us study the experimental results of photoelectric effect based on Einstein's equation. According to Einstein, photoelectric effect is instantaneous. He treated the collision between a photon and an electron as the collision between two microparticles. So if it is collision between microparticles, definitely it must be the instantaneous process. Now second result is, if nu is equal to nu naught, then from the above equation kinetic energy is 0. That is, photoemission is just possible. When frequency of photon is equal to threshold frequency, the electron just comes out from the metal surface, but kinetic energy will be 0. If nu is greater than nu naught, then from the equation kinetic energy is positive, that is, photoemission is possible. When frequency of photon is greater than threshold frequency, the electron comes out from the metal with some kinetic energy. Above threshold frequency, the maximum kinetic energy increases as the frequency of incident radiation increases. Let us see next result. If nu is less than nu naught, then from the equation kinetic energy is negative, but kinetic energy never be negative. So when frequency of photon is less than threshold frequency, the electron does not come out of the metal surface. Photoelectric current is directly proportional to the intensity of incident radiation. Here one photon interacts with only one electron. As intensity of incident radiation increases, number of photoelectrons emitted increases. Hence, current increases. So these are the results explained by Einstein with the help of his equation kinetic energy is equal to h nu minus h nu naught, where h is Planck's constant, nu is frequency and nu naught is threshold frequency. This photoelectric effect is the strong evidence to the particle nature of light. According to Einstein, photon is associated with definite value of energy and momentum. This is the property of particle in motion. Hence, light is considered to have particle nature. Light interacts with matter as a packet of energy. This packet of energy is called photon. So what is photon? It is the packet of light energy. Now let us see some characteristics of photon. The rest mass of photon is 0. Photons are electrically neutral. It travels with the speed of light. Energy of each photon is given by E is equal to h nu, where h is Planck's constant and nu is frequency of photon. The momentum of the photon is given by P is equal to m into c. the energy of photon is directly proportional to frequency of the photon. Now let us take very interesting one, that is wave nature of matter. De Broglie, name of the scientist, he made a bold suggestion. Like radiation, matter also has dual nature. According to him, matter, like electrons, exhibits wave particles under wave properties under suitable conditions. This logic is based on the following consideration. First one, say nature is symmetrical. The two basic principal entities of nature are matter and energy. If energy radiation exhibits dual nature, then matter also must exhibit dual nature. So de Broglie proposed about matter waves. Then what are matter waves? The waves associated with the moving material particles are called matter waves or de Broglie waves. The wavelength associated with these waves is called de Broglie wavelength. Now let us see the expression for de Broglie wavelength. Energy of photon is given by E is equal to h nu, where h is Planck's constant and nu is frequency of radiation. If photon is regarded as particle of mass m, then its energy is given by E is equal to mc square, where c is velocity of electromagnetic radiation. So here we have two equations. One is E is equal to h nu and E is equal to mc square. So let us equate these two. If we equate it, we will get E is equal to h nu, E is equal to mc square. But nu frequency is equal to c divided by lambda. Lambda is wavelength. So if we substitute this value, we will get hc by lambda is equal to mc square. So one c get cancelled. So you will get h divided by lambda is equal to mc. Adjust the terms here. You will get lambda is equal to h divided by m into c. This m into c is nothing but it is momentum p. So lambda is equal to h divided by p, where p is momentum of the photon, h is Planck's constant and lambda is de Broglie wavelength. So equation 2 is expression for de Broglie wavelength. So that is lambda is equal to h divided by p. De Broglie suggested that this equation is applicable to both photons and other material particles. So this equation can be expressed in other forms. Now let us see those other forms one by one. First one, just now what we learned, no, that one. Expression for de Broglie wavelength of a photon. Lambda is equal to h divided by m into c. Then expression for de Broglie wavelength of a particle moving with a velocity v, then lambda is equal to h divided by m into v. Instead of c, you have to write v. Even we can express this de Broglie wavelength in terms of kinetic energy E. So how to express? The expression for kinetic energy is E is equal to half mv square. Let us take one m extra and let us cancel it. So we will get 1 divided by 2m. Take one m extra, so it becomes m square v square. But m into v is momentum p. So numerator will be p square divided by 2m. So kinetic energy is equal to what? P square divided by 2m. If you shift the term, you will get P square is equal to 2me, or P is equal to square root of 2me. Substitute this value in de Broglie wavelength. That is lambda is equal to h divided by P. So we will get lambda is equal to h divided by square root of 2me. This is expression for de Broglie wavelength in terms of kinetic energy. Even we can express de Broglie wavelength in terms of potential V. So formula is lambda is equal to h divided by square root of 2mqv, where m is mass of charged particle, q is magnitude of the charge, and v is potential. How to get this expression? For that, here one hint is given. We have one formula, that is electric potential is equal to work done divided by charge. Here work done is considered as kinetic energy. So W is equal to K, that is kinetic energy, is equal to charge into potential. In last slide, kinetic energy is equal to P square divided by 2m we have written. So substitute it. So you will get QV is equal to P square divided by 2m. Now P is equal to, if you write, you will get square root of 2m QV. Substitute it, you will get lambda is equal to h divided by square root of 2m QV. Here magnitude of the charge we have considered it as Q. If that charge is electron, then this expression takes the form lambda is equal to h divided by square root of 2m EV. Instead of Q, you have to write E. E is charge of electron. So these are different forms of de Broglie wavelength. You can expect 1 mark question here. So try to remember different forms, even it will help us to solve the problems. Now the wave nature of electron was first experimentally verified by Davisson and Germer. So Davisson and Germer experiment confirms the wave nature of moving electrons. The wavelength of matter waves calculated by Davisson and Germer experiment is lambda is equal to 0.165 nanometer, and calculated by de Broglie wavelength is lambda is equal to 0.167 nanometer. Now let us see Davisson and Germer experiment, how it works. Here if you see, the experimental arrangement is as shown in the figure. It consists of an electron gun, and it comprises a tungsten filament F. It is coated with barium oxide and heated by a low voltage power supply. You are observing LT there, that is low tension battery. To heat the filament it is used. This electron gun is connected to HT, that is high tension battery. Then you are observing A there, that is anode. It is in the form of cylinder with a fine hole, and at a proper distance from this filament nickel crystal is placed. Then movable collector is connected with galvanometer, and this galvanometer is instrument which is used to detect the presence of current. So this entire apparatus is enclosed in an evacuated chamber. Let us see how it works. When filament gets heated with the help of low tension battery, electrons are emitted. The emitted electrons are accelerated by this high tension battery. With the help of this high tension battery, desired velocity can be maintained by applying suitable voltage. This experiment was conducted by adjusting the voltage in between 44 volt to 68 volt. When electrons are emitted by the filament, then are accelerated to desired velocity by applying suitable voltage, then are allowed to pass through the anode, which is in the form of cylinder with a fine hole. When the electrons passed through this anode, they form a beam which falls on the surface of nickel crystal. The electrons are scattered by the atoms of the nickel crystal. This intensity of scattered electron is measured by the electron detector. The detector can be moved on a circular scale and is connected to sensitive galvanometer. So the variation of intensity with the scattering angle theta is obtained for different values of accelerating voltage. It was noticed that at 54 volt, a strong peak intensity of scattered electrons was appeared. From the electron diffraction measurement, the wavelength of matter waves was found to be 0.165 nanometer. Then according to de Broglie hypothesis, the wavelength of wave associated with electrons accelerated by voltage V is equal to 54 volt is 0.167 nanometer. This shows that there is close agreement between experimental value and theoretical value. This proves the existence of wave nature of electrons. So, particle nature as well as wave nature of electrons we have learnt in this chapter. That's why the name dual nature of radiation and matter. So, based on this, there are some questions. Try to write answers for these questions. I hope you have understood all these. Thank you.